Yo, what's up everyone? Today we're going to be doing the States of Matter section of the 2021 USNCO local exam. So this is going to be from questions 13 through 18. Okay, so let's start with 13. The diagram is a microscopic view of a snapshot of a substance at equilibrium, with the circles representing molecules and the arrows the molecules' velocities. What state of matter is depicted? Well, in this diagram, you obviously have kind of molecules that are a little bit spaced apart. The fact that they're spaced apart and the fact that they have some sort of velocity means that it's not going to be a solid. It's not going to be a solid. It can't be a gas because a gas would be far more spaced out. And it also can't be plasma. So it has to be B, which is a liquid. So liquid is kind of spaced apart. They have some sort of velocity. They're moving a little bit, but definitely not as much as, say, a gas. All right, let's go to question 14. The vapor density of which fluorocarbon is 6.17 grams per liter at 23 degrees Celsius and 1 atmosphere of pressure. So we have 6.17 grams per liter. We would preferably want this in something grams per mole. The reason this helps us is because if we have this is just the molar mass. We can just see if the molar mass of our four options here matches up to the molar mass we calculate. So how do we get the liters into moles? If this question gave us instead standard conditions, which are 25 degrees Celsius and 1 atmosphere, we could have used the conversion that 1 mole of a gas is going to occupy 22.4 liters of volume. But we're not at 25 degrees Celsius and 1 atmosphere. We're at 23 degrees Celsius and 1 atmosphere. So we have to figure out how many liters 1 mole of a gas occupies at 23 degrees Celsius and 1 atmosphere. And we can do that using PV equals nRT. So our pressure is going to be in 1 atmosphere. Volume is what we're trying to find out. N is going to be 1 mole. That's what we're trying to find out for. R is going to be 0.08206 plus some units. And T is going to be 273 plus 23 Kelvin. So after you do all this, your volume is going to come out to 24.3 liters. Now that we know that we have 24.3 liters of volume in 1 mole, we can multiply 6.17 grams per liter times 24.3 liters to get that our gas should have a molar mass of about 150 grams. And so which one of our answer choices has a molar mass of about 150 grams? That's going to be answer choice A. So that's 14. Let's go to 15. What is the principal intermolecular force that must be overcome when N-hexane is vaporized? So N-hexane is a long organic molecule. This implies that you're going to be dealing with major London dispersion forces, and the fact that you're dealing with just a carbon chain means that it's going to be nonpolar. You're not going to have hydrogen bonding. You're not going to have dipole forces. So A and C are out. B, covalent bonding between carbon atoms. Those aren't intermolecular forces. Those are intramolecular forces. So B is wrong, and therefore D is the right answer. That's 15. Let's go to 16. The melting point of water decreases with increasing pressure. What is the best explanation for this observation? So when you increase pressure, what's happening is that you're making the substance tighter, more tightly packed. Now, the thing with water is that its liquid form is more dense, meaning it's more tightly packed than its solid form, which is ice. So this is the reason why ice floats on water. Water is more dense than ice. And so when you go to increase the pressure and make it tighter, it goes into its liquid form. So let's see which answer choice best represents this explanation. A, liquid water is denser than solid water at 0 degrees Celsius. That's totally true. That does explain why this happens. B, melting point of ice is endothermic at 0 degrees. That wouldn't really make sense. The vapor pressure of liquid water is lower than the vapor pressure of solid water at 0 degrees Celsius. That shouldn't have an effect. Solid and liquid water cannot coexist at equilibrium 0 degrees at pressures different from 1 atmosphere. I'm not sure if this is true, but this is wrong. So A is the right answer. Alright, that's question 16. Let's go to 17. A cylinder containing a mixture of carbon monoxide and carbon dioxide has a pressure of 2 atmosphere at 93 degrees Celsius. The cylinder is then cooled to negative 90 degrees Celsius, where carbon monoxide is still a gas, but carbon dioxide is a solid with a vapor pressure of 0.5 atmosphere. The pressure in the cylinder at this temperature is 0.90 atmosphere. What is the mole fraction of carbon dioxide in this cylinder? Now, let's draw the final chamber here. In the final chamber, 0.25% of that is going to be from the carbon dioxide. The carbon dioxide is going to have a vapor pressure of 0.25 atmospheres. Now, on the bottom, the majority of it is going to be the carbon monoxide. Now, the carbon monoxide is going to represent the entire pressure of the chamber minus the pressure of the carbon dioxide. So that's going to be 0.90 minus 0.25, which is 0.65 atmospheres. So carbon monoxide in this chamber has a partial pressure of 0.65 partial atmospheres. This does not tell you what its pressure was initially. In the cylinder with the pressure of 2 atmospheres, what pressure did the carbon dioxide have? Well, if you notice, the temperature in the initial chamber is double the temperature of the second chamber. Now, this is important because pressure and temperature are proportional when everything else is kept the same. What that means is that if the pressure at the second chamber was 0.65, the pressure in the initial chamber is going to be 1.3 atmospheres. This is coming from the fact that as you double your temperature, you also have to double your pressure. Okay, so now that we have the pressure of the carbon monoxide in the first chamber, we could finally find out the mole fraction of carbon dioxide in the cylinder. This is because if the entire chamber had a pressure of 2 atmospheres, then that means that the 2 atmospheres minus the 1.3 atmospheres of carbon monoxide is going to give you 0.7 atmospheres of carbon dioxide. The mole fraction is going to be equivalent to the partial pressure. So the partial pressure of the carbon dioxide is going to be 0.7 atmospheres over the total pressure, which is 2 atmospheres. So this is 0.35. That is your mole fraction, which is also the same thing as your partial pressure. So the answer is C, 0.35. Let's go to question 18. A mineral containing only copper and oxygen adopts the cubic unit cell shown below. What is the formula of this mineral? So on the we have a bunch of coppers, bunch of oxygens. We have to count them. The first thing that I see is 8 of these corner oxygen atoms. So 8 corner atoms are going to represent 1 full atom. This is because 8 corner atoms represent 1/8 each. So that's going to represent 1 oxygen atom. And we also have 1 oxygen atom in the center for a total of 2 oxygens. That looks like 20, but that's a oxygen. Okay, now let's count the coppers. We have 1 copper, 1, 2, 3, 4. We have 4 coppers. So it's going to be copper 4, oxygen 2, but that can be simplified to copper 2, oxygen, which is answer choice A. And that is the 2021 States of Matter section. I hope this was helpful. I hope you were able to learn something, and I hope to see you later. Thank you.